What was the moment you realized that quantum computing will become a real threat to crypto and that someone needed to build a company like Quip?
Everyone has known that quantum computers are going to be a threat for a long time. Even Satoshi, in the early days of Bitcoin, was talking about how quantum computers would be a threat and they would have to upgrade all of these factors in Bitcoin to respond to that threat. It always felt really far off. There's a 10% chance that we have a cryptographically relevant quantum computer by March of 2028. If you believe that that's true, you should be acting today. And that's exactly what we did, is we started working on that problem.
What's been the hardest technical problem in building a quantum-powered network so far?
Honestly, the hardest problem is that
Thank you very much to Colton Dillion for joining CCM today. Colton is a crypto quantum computing founder focused on post-quantum security and decentralized computing, and the co-founder and CEO of Quip Network via Post-Quantum Labs. Thank you very much for joining us, Colton.
Thank you for having me, Giuseppe.
So let's start with, what was the moment you realized that quantum computing will become a real threat to crypto and that someone needed to build a company like Quip?
Everyone has known that quantum computers are going to be a threat for a long time. Even Satoshi, in the early days of Bitcoin, was talking about how quantum computers would be a threat and they would have to upgrade all of these factors in Bitcoin to respond to that threat. But it always felt really far off. But then in November of 2024, Google released an announcement saying that they had taken 10 of their Willow chips and they had connected them together. And in that result, they said that the more chips they use, the fewer of the physical qubits they had to use for error correction. And this factor was actually exponential. So the more chips you used, the exponentially more compute you could actually get out of the physical qubits. And so my co-founder Rick Carbeck and I, we saw this and we said, well, this might be the Moore's Law moment for quantum computing. And we actually put together a model at quantumdoomclock.com where we took all of the commercially available processors out there and said, what are the qubit counts? What are the error correction rates? What is the qubit fidelity? How long can you keep the quantum states around for? And we decided to plot these factors on a line of best fit for an exponential growth curve. And it said we should expect that there's a 10% chance that we have a cryptographically relevant quantum computer by March of 2028. And so, if you think a 10% chance is not that much, take the $1 trillion Bitcoin market cap and multiply that by 0.1% or by 10%, and you're still looking at a $100 billion issue. So if you believe that that's true, you should be acting today. And that's exactly what we did, is we started working on that problem.
A lot of people say quantum is still far away, even after Google's recent paper that argues that quantum computers can break Bitcoin and Ethereum in just as little as 9 minutes. Why do you believe the industry needs to act right now?
So all of these things take time, right? You can't just flip a switch and upgrade your cryptography. If you tried to convince a bank to do that, they would tell you you're crazy, that you have to plan years in advance for a migration of that magnitude. And so the idea that we're going to take a decentralized network and do that rapidly without problems is, very optimistic. And so you have to get started today. Even if you think that this isn't going to be a problem until 2030 or 2032, 6 years is not a very long time to do an upgrade of this magnitude. And it's not just going to affect the cryptography, it's also going to affect the operators, right? A lot of the signatures that we know about, they're very large. And so the miners don't want to upgrade right away because that means more costs for them. Some of the signature algorithms don't use the same hardware, or they can't rely on the same advantages that our existing hash-based and elliptic curve-based cryptography uses. And so you might also have to upgrade your signing hardware. And all of these investments take time. They have to be planned in advance, and it's not just a switch you can flip. And so the earlier we can get started, the better we can do that planning, and the less likely we are to have network disruptions or issues that are a result of trying to rush one of these migrations.
Just talking about, you saying, taking time, you've described Quip in the past as building the worldwide quantum computer. What does that actually look like in 5 or 10 years from now?
Yeah, so when we say the worldwide quantum computer, we mean that literally. One of the things that makes quantum computing different from classical computing is that you can entangle the states on 2 processors. And so the output of one processor relies on the output of the other processor. And it doesn't matter if you separate these things by space and time, the output of the first processor will always be correlated with the output of the second processor. And so what does that look like in 5 to 7 years? There's a lot of research that has to be done still to connect these things around the globe, but we're already connecting these things within one data center. And so in 5 to 7 years, we're hoping that we're connecting them between 2 data centers. You know, we're working with universities and government labs along I-25 in New Mexico, Colorado, and Wyoming to try and build the first legs of this quantum internet and to be able to have these quantum computers operate together on the same problem. And so in 10 years, in 20 years, that's when we really start to see these global mining pools, we hope, where we're literally entangling together processors that may be separated by a lot of space and a lot of time. China just demonstrated quantum key distribution over 1,000 kilometers. And so we're rapidly making progress on being able to create these large distributed networks.
You and the co-founder talked about quantum power crypto mining and also the Quip token. Can you explain how that works and what role the token plays in all the network incentives and security?
Yeah, so the initial proof of work that's supported by the Quip network is something called an Ising model. And it turns out that this Ising model is really good for representing, one, electromagnetic spins and how they fit together in a 2-dimensional or n-dimensional system. But that you can actually transform real-world optimization problems into this Ising model problem. And so essentially what we're doing is we can say, if you're FedEx or DHL or UPS and you need to figure out how do I deliver these packages most efficiently? How do I pack as many as I can into a truck? How do I schedule my deliveries so that the drivers are waiting around the least amount of time? How do I get them to visit locations so that they're using the least amount of fuel? We can actually take all of those problems and transform them into this problem that the quantum computer is really good at. And this is our proof of useful work. So essentially, you solve these problems of trying to get the overall system to have the least amount of energy or the best possible answer. And it turns out that you can take these real-world industrial problems and map them directly to that proof of work. And so the quantum computers, it seems right now that they're very competitive. We can take a very large cluster of GPUs, 80 H100s, and pit them head-to-head against that quantum processor. And the quantum processor will win 92% of the time based on our early testing. And so we're actually inviting the rest of the research community out there to try and improve the classical implementations so that we can show whether this is a real result or whether this is just an artifact of us being a small team.
Well, you mentioned real-world applications, and so my question is, beyond crypto security, what are the first real-world applications that you expect quantum-powered networks like yours, like Quip, are going to unlock?
Yeah, so I already mentioned logistics, being able to deliver things faster, better, cheaper everywhere around the world. One of the other applications we think is in finance, doing portfolio optimization, risk management, volatility, forecasting. All of these are things that we believe the quantum processors are much better than existing platforms at being able to calculate. But the thing that most people are really excited about is for manufacturing. is how do we simulate these new materials and basically create a lab on a chip. So that way, when I want to produce the next material that's going to build our hypersonic planes that fly at extreme altitudes and are extremely fuel efficient, that I don't have to spend $800 million on lab testing and manufacturing processes just to see whether it's going to work or not. I can get really, really high accuracy and precision in trying to predict the properties of this material before we ever try to assemble it in the lab. And so there's a lot of really interesting research going into that. And then the original reason that a lot of people invested in quantum was AI. That essentially all these models that were spending gigawatts of energy every hour trying to produce, essentially the quantum processors, once they are mature enough, will use kilowatts instead of gigawatts. And so these factors of improvement compound, where you can get bigger, better, denser models into a smaller space. They're more accurate. They use less energy. All of these are promises of quantum computing that are still very early in the validation, but there's a lot of really good evidence that this is going to be the case. I can tell you today that to run a 75 pixel by 75 pixel image recognition model, the quantum computer will produce better outputs faster with cheaper training and cheaper inference.
What's been the hardest technical problem in building a quantum-powered network so far?
Yeah, honestly, the hardest problem is that the hardware is still very early, and so there's not a lot of open source software that makes it easy to use the hardware. If I want to get access to a quantum machine, I can't just go to AWS or Google Cloud and say, hey, give me some on-demand compute. They'll say, well, we can simulate a quantum computer for you, but otherwise you have to talk to one of our cloud partners. And then you go talk to the cloud partner and they say, okay, well, first of all, it's a $40,000 entry fee just to get access to the computer, maybe $70,000 to $80,000. And you have to get into a 3 to 6 month consulting process with us so that we can help you figure out whether your industrial problems are really going to be solved by our computer, or whether you know enough about quantum computing to get a good result. And so all of this is a huge roadblock to even getting started, to even understanding whether quantum computing is good for your application. And so that's really one of the problems that we're trying to solve, is how can we take that time from I'm curious about quantum computing to I want to get my first valuable result from quantum computing, and make that period of time as small as possible. And so, we're building a smart contract network. You'll be able to use the Quip token to purchase this idle compute that's not being used by anyone else, and to run smart contracts that were already written by people who are experts in the technology. And so you don't have to know anything. You don't have to have a PhD. You just have to know, hey, this is a problem that I want to solve, and I can get my data to match whatever the API is asking from me.
You mentioned Google Cloud, Amazon Workspace. I also had IBM. Are you building alongside these traditional cloud providers, or are you competing with them?
Yeah, so we want to be an asset to these cloud providers. We don't want to be a competitor. So when we work with D-Wave, for an example, we're selling spot compute on whatever excess capacity they haven't already placed with their customers. When they sell a machine to a customer, we want to give that customer a really good high probability that they can pay off the loans that they use to purchase that computer by mining on the network, by providing that compute to the demand that exists on the open marketplace. And so it's really important to us that the manufacturers, the cloud providers, they see us as an asset, as a way to help people who are curious about quantum, who are ready to buy a machine, to make sure that they're getting the most value that they can out of that machine. And ultimately, that we're creating an open source library where anyone in the world can submit these solutions, and anyone in the world can request the answer from those solvers. So that way, we're not just creating these siloed pits of IP that nobody has access to, and we can all share the very limited talent that exists in quantum, and hopefully accelerate the process of creating more of that talent. And so all of these things, we hope that IBM, D-Wave, IonQ, they see us as an ally and not as, somebody trying to eat their lunch.
And have you already had any interaction with these big names?
So we just announced last week that D-Wave is one of our first suppliers on the network. I can't disclose some of the other conversations that we're having, but we are talking to multiple suppliers around the world, in China, in the US, in European countries, and the rest of North and South America. And, we want this to be a network for everybody, that if you have a processor of any type, whether it's quantum, classical, a GPU, CPU, a tensor product unit, we can support your hardware and help it to solve solutions for real customers.
In your career, you've built across fintech, crypto, and now quantum. What's the biggest lesson that you've learned as a founder across all of those industries?
I think the biggest lesson is make sure to choose a problem that resonates with people. That if you can create a one-liner that either unlocks people's imaginations or helps them to see how their life could be different, that makes a huge difference in having that core mission that will drive you to success. With Acorns, it was investor spare change, right? It felt like something really accessible to people. A lot of people had never invested before. And we saw in our first year that we had thousands of people who were saying, this is the first time I've saved $300 in one place. With Degen, it was tip your friends for making memes, right? Get paid to make memes is a really powerful thing for people these days, because there's a lot of content out there that takes a lot of time and energy to produce, and a lot of people just aren't getting paid for it. And this created a really rich community for people to interact to each other. And we really believe we have that with Build the Worldwide Quantum Computer. We want people to think fast and think together in order to solve the world's toughest challenges that no other platform in the universe can solve. And we really believe in that mission, and we hope that we can make it a reality.
You already talked about the future of quantum computer and the Quip, but when do you realistically think that quantum computers will become powerful enough to break today's crypto infrastructure?
Yeah, so, we stand by the quantum doom clock prediction that March 2028 is our 10% chance that we will have a cryptographically relevant quantum computer. And we don't think that's insane. A lot of the largest companies in the world are saying 2032 at the latest. If you ask the NSA in the United States, every new government contract has to be quantum resistant by 2028. All old contracts have to be deprecated by the end of 2030 and have to be completely phased out by 2035. So the people who should know best are saying absolutely nobody in the government should be using classical cryptography or non-quantum resistant cryptography by 2035. And so if you think that they're being paranoid, maybe that's true. But they're also the people who have the access to the most information to make the best informed decisions. So, our prediction is that definitely by 2032, we will have cryptographically relevant quantum computers. And you can see that in all the papers that have been released. 2021, 20 million physical qubits. 2024, 1 million physical qubits. 2026, 100,000 physical qubits, and now maybe even 10,000 physical qubits, if you believe the recent paper from Neutral Atoms. And we're also compressing the time period, where even the Google result from last week said that now we can expect that the ECDLP, the elliptic curve problem, can be solved in under 10 minutes, which means that every Bitcoin transaction is vulnerable.
The fact that this will be successful is all a matter of research, as you said before, or it's also a matter of funding? They are correlated?
They are definitely correlated. The more funding there is, the more research that happens. Obviously, governments and state actors are very ambitious, and they believe that this is a critical strategic technology to be able to break other states' cryptography, to be able to improve their missile defenses, to have better quantum communication, make sure that secrets really stay secret. All of this is existential for all of these states. And so there's a lot of funding that's being put into this research area. But there are many problems that still need to be solved. There are algorithmic improvements. There are improvements that need to be made to error correction, to actually being able to communicate between two processors that are separated by a photonic link. There are many different ways that we can make improvement, and all of these improvements compound. Right. So the instant that you have improvement in error correction, you can also use that to reflect that back on the other problems that still exist in the computational space. And once you have horizontally scalable computers, now you can essentially scale up your computers indefinitely. You don't have to wait for another generation of hardware to come out. And so any progress on any one of these verticals can rapidly translate into huge progress for the whole sector.
One last question for you. If Quip succeeds, what changed about the internet, crypto, or computing that people, especially not the expert one, might not expect?
If Quip succeeds in everything we want to succeed at, the entire world will be different, right? AI will be cheaper, faster, smaller. You'll be able to fit it on your phone. We'll be able to create new materials that make room temperature superconductors that are able to put quantum processors into that phone. If we succeed, we can do true decentralized supply chains where we're calculating the difference between, what a courier in India can do versus a courier in Pakistan. And we're able to facilitate the insurance contracts and all of the complexity of delivering those objects around the world. And so if we succeed, it's a step change in what we're able to do as a civilization. And I really believe that we will be solving problems that no other platform on Earth can solve.
Perfect, Colton. Thank you very much for your time. Thank you for joining CCN for this interview.
Thank you, Giuseppe.